How are you? I hope you are fine. And let's start with lecture number 4, or lecture number 14, right? And in this lecture, what we're going to do, we will going to do the few things which are very, very important. We will start a new chapter, which is also called as thermal heat or thermal physics, you can say. Thermal physics. But before we actually start thermal physics, let's have one small topic, which is definitely a part of that as well. We have to do this. So basically, what exactly it is. So what is it? It is called pressure. Now, what is pressure? In case of pressure, when you say so pressure is just defined as force per unit area, right? So it is called force per unit area. So you apply a force, and that force is actually divided by the area, and that is what we called as force per unit area, right? So force per unit area is called as pressure. Now, what will be the unit for that? The unit for that is newtons per meter square, right? And it has another unit as well. We called it pascals. So Newton per meter square is called as Pascal as well. This is a general formula for the pressure. You can use it in solid, liquid, gases. Mostly it is used in solid cases, because for liquid, there is a small bit different formula. And what exactly it is, we will come to that. But before we go into the liquid type, let's talk about example. Now, what is the example going on in this? Example, you can see that, because if you check the formula, pressure is equal to force per unit area, right? So pressure is equal to F upon A. When you say so, it means that if you want to increase the pressure, the area of contact should be as small as possible. So technically speaking, you can see here, so drawing pin has a sharp pointed edge here, right? With a very small area. So technically speaking, if the area is smaller, you need to apply less force and pressure will be larger on the surface. So that concentrates this force and creates a large pressure over a small area, right? This allows the drawing pin to be pushed into the wall. So basically, area of contact should be as small as possible, means the pressure will be as big as this is. And if the area is smaller, you need to apply less amount of force for a larger value of pressure. This is for the solids, right? Now, this can be a question which is there. You can check it out. In this question, what it says is, the pump creates a pressure of a liquid of this 5.28 pascals to move the platform up. Calculate the force that the liquid applies to the piston. This is the cross-sectional area given, right? Now, very simple is pressure is equal to force upon area, right? Pressure is given as 5.28 into 10 raised to the power 5, and the area of cross-section is 2.73 into 10 raised to the power minus 2. That gives you your force, how much force is applied. If you just do that on a calculator, let's see, 5.28 multiplied by 2.73, what is the value coming up? 14.41. So it's 14.41 into 10 raised to the power 3. If I write it properly, then it will be 14,410 Newton, right? So this is the force which is applied on this platform, okay? So this is what the point is. This is how the things are. Now, the next small topic is relevant to that is pressure in the liquid. Now, what are the things which are basically, you can see, depends on it. The important part is the pressure in the liquid is equal to rho g h. Now, this h is not a height, this h is a depth. So you can say more the depth is, the more will be the pressure, right? Plus the density. More the density, more the pressure. Like if you check it out about the, seas and all that, if you go further down into the sea, the pressure will be more and more and more. So if the depth under the water increases, pressure in the liquid increases, and the density, if increases, definitely the pressure also increases. I can show you, you can understand that. This is a diagram which is here. So the weakest is at the top because the pressure will be as low as possible. Here at the bottom, because the depth is more as you go downwards, so you can say the pressure will be as strong as possible, right? So basically, the formula says that if the depth is more, the pressure will be more in the liquids. And it always, you can see pressure always exert in all the direction. The formula is very simple. Change in pressure is equal to rho gh. G value means 9.8 meters per second square. Delta H can be change in height, or you can say simple height. Sometimes it's written as 9.89 newtons per kg. So both means the same. No difference at all, right? They're saying calculate the depth of water in a swimming pool. Okay. So D needs to be found out. Where pressure is given. And pressure is given as 20 kp. Kp means kilopascal, which means 20,000 pascals. The density is given as 1000 kg per meter cube. And G value is given as 9.8, and it is always 9.8, whether they give you or not. So they are saying height. They need to find out. Height, not height, means depth. So pressure is equal to rho G H. Remember that H will always be the change in height. In that case, it's simple height, right? So height equals to P divided by rho G. P is given as 20,000. Rho is equal to 1000. Multiply by 9.8. These three zeros and these three zeros cancel. So 20 divided by 9.8. What is the value? 20 divided by 9.8 will give you 2.04. So height is 2.04 meters. This is the height, and in this case, this is the depth. Change in the height of the column, or you can say the depth inside, because technically it is the depth, right? So pressure acting on the object in a liquid changes with the depth. So you can call it height, but not upward, in the downward direction. In the downward direction. Now the next topic, this is for the liquid. So there will be two pressures here. One pressure is F upon A normally for the solids, and for liquid, it will be P is equal to rho G H, right? This is the end of this, topic pressure. Now, as I just told you, we have a new topic, and this topic is called as thermal physics. Now, what exactly is meant by the thermal physics? As the name suggests, thermal means heat. Physics means physics. So it means related to heat. Physics related to heat is called as thermal physics. Now, once we have to discuss that, right? So technically speaking, first of all, that implementation should be applied on different type of substances. Now, how many substances you have it? So technically speaking, we have four type of, matter we have it, solid, liquid, gas, and we do have a plasma, but we are not talking about plasma here at this point. So solid, liquid, gas, there are three type of, materials we have it, and we are discussing these three materials first of all. So in thermal physics, the first topic is to discuss this solid, liquid, and gas. What are these and how they look like and all that? Then we will definitely discuss what is heat and temperature as well. But first, let's quickly discuss that. Now, important part. First of all, remember that in thermal physics, we believe that, and that is what we call as kinetic molecular theory. We will discuss it in a few minutes. Kinetic molecular theory, KMT. Kinetic molecular theory. It says that these particles, these materials, solid, liquid, gas, are based on molecules, right? And definitely molecules are always moving. They have a typical arrangement. There is a typical arrangement of these particles. We do sometimes call them particles, sometimes we do call them molecules, so don't be confused about it. Now, as far as arrangement and the motion of the particles are concerned, the first point for solid, liquid, and gas. Check it out. Molecules are very, very close. Like, for example, if I draw a solid, let's suppose this is a solid. Molecules are very close to each other, or you can say particles are very, very close to each other, like this. Very close to each other. So particles are very close to each other and they have a regular pattern. They have a proper shape. Because they have a proper shape, you can simply say that they have a regular shape you can say particles are very nearby. And the next part is they are vibrate like this, which is called as moving to the fixed position, to and fro, like this. So this is what the solid is. The first part of liquid are still very close, but not as close as solids. They are like this. They are in the form of clusters. They are nearby, but they are not as near as solids. There are gaps. They are in a regular pattern, but definitely, as I just told you, they do not have as regular pattern as solids. The particles movement is they are sliding past over each other because they have spaces in them. Next is gases. Gases are very far away from each other. You can say particles are like this, very far away from each other. You can say 10 times further apart of each direction, widely separated, with random direction, with random at high speeds. Right? Remember that in case of liquid and gases, the particles are moving as a special term we use them for their motion. We call them Brownian motion, which we will talk about in a few minutes. So what are the properties of a matter which is solid, liquid, and gas? As far as state is concerned, density, for example, density means how close in a particular, because it's a volume, right? Mass per unit volume. So for the solid, mass per unit volume is so high because particles are very near to each other. In a liquid, it's medium. They are in the form of clusters, and in gas, it's very low. Arrangement of particles, they are regular pattern in solid. In case of liquid, they do have a regular arrangement, but definitely not as compared to the solid. They have less, and they are randomly arranged. As far as the movement of a particle is concerned, they vibrate along a fixed position. In case of liquid, they move about each other, or they can slide over each other. And they are more quickly in all the direction. I told you these two movement of particles in liquid and gases are also named as Brownian motion. We will talk about this in a minute. In case of solid, they have a low energy because they are very nearby. Liquid particles, they are greater energy. And the gas particles, because they are quite far away from each other, they got the highest energy, right? So this is what the point is. Next is This is what we are talking about, as I told you previously, in case of kinetic molecular theory. Kinetic molecular theory. As I told you previously, that we will discuss that. So I will discuss it here. First of all, the important part is we believe that whether it's a solid, a liquid, gas. Now, first of all, remember that in this case, we normally discuss the gases, motion of particles in gases. Remember that. So when you talk about kinetic molecular theory, we mostly talk about the gas. What we believe it, that kinetic molecular theory says that gas particles are mostly molecules. So in gas, there are molecules which are randomly move here and there with a very high speed. As I told you, we call them Brownian motion. Random motion means they're going here, there. You can see here. They're just going here and there. They strike with the container in which it is placed, and they do collision. And they do collide with the walls of a container with the other molecules as well. No specific path, just go here and there. Next is the pressure which they actually exerted on this container, right? It is the pressure which they exerted on the container due to the collision of particles with the wall of a container. Next is when the particles travel fast, they collide with the walls more frequently, which means the greater the pressure. Now, this is very interesting point at this point. What is temperature? It's written here, so it's time to discuss the temperature here. There are two proper definition. In case of KMT, when you talk about that gas particles, gases are based on the molecules and all, what we call them average kinetic energy of a substance, of a gas or substance is called as, any substance is called as temperature. Heat is total kinetic energy of a substance is called as heat. So heat means when you give kinetic energy, when you give heat to the molecule, they will go here and there due to this energy provided by the source or whatever. And that total kinetic energy is called as heat. But average one is called temperature. Temperature has another definition as well. Degree of hotness or coldness is called as temperature. But at this point, we will talk about kinetic molecular theory base, which is called as average kinetic energy of a system. So basically, when you provide the temperature, so average kinetic energy of the substance of the molecules within the gas particles, within the gas particles, kinetic energy do increase. So molecules go here and there. They strike more frequently with the wall of the container, and in that way, pressure increases. All right. Now, few important points which needs to be discussed at that point. I quickly say another thing because at this point, we already discussed that. Now, few points which I didn't discuss in case of solid, liquid, and gas. Very important. When I say that particles are tightly packed or they have a regular pattern, I can say that there are intermolecular forces between them. Intermolecular forces means because they are very close to each other, so they will attract each other. There are forces between the molecules of solid particles between them. Strong forces. That's why they are attached together. Okay? So they have strong intermolecular forces between them. I'm talking about the molecules or the particles. In case of liquid, they have a medium intermolecular forces between gas molecules. In case of gas, what happened? They're very weak intermolecular forces between gas molecules. I've written here gas molecule. It's not gas, it's definitely liquid. So medium intermolecular forces between the molecules. Here in case of gas, weak intermolecular forces between the gas molecules. Next is if they do not have intermolecular, if they have strong intermolecular forces, so they do not have intermolecular spaces. Say very small or no intermolecular spaces between the molecules or particles of solid. They have very small intermolecular spaces between its molecules, or you can say particles. In case of gas, very large or large intermolecular spaces between its molecules or particles. One more point, because solids are tightly packed, so they are not compressible. You cannot compress them. They will be break, but cannot be compressed. Liquids, still, they can take any object shape in which you are placing them, but they are not compressible. Gases, they can take any shape and do not have fixed volume, or you can say they do not have fixed volume anyway. Solid have a fixed volume, liquid has a fixed volume, and they are easily compressible as well. So these are the points which I had to give you here. Now, let's talk about once again pressure. We already talked about this formula previously, that force got pressure in terms of, when you talk about pressure and force relationship, particles of the gases, then pressure can be equal to F upon A, force per unit area. The force you applied upon area will be technically pressure. Now check it out what exactly it says. It says that when the particle moves faster, right? When the particle moves faster, they have more frequent collision with the container walls, and these exert a greater force. So basically, if number of collisions are more, forces will be more. With the, you can say, collisions with the wall of a container is more, pressure more, force more, so pressure will be. As far as area is concerned, lesser the area of contact, more will be the force, and less will be the force if is applied, but more will be the pressure. So if force exerted per unit area is greater, more frequent the pressure exerted, the greater the force. Okay. Now here the small topic which is a part of our syllabus, as I told you, the particles movement in case of gas and liquid is called as Brownian motion. The name is Brownian. So kinetic theory of matter says simply that all matter is made up of tiny particles, which was discovered accidentally by the scientist named Robert Browning. And in this case, the Robert Browning said the random motion of the pollen grains in water, which he sees under a microscope. So his observation could not be explained at that time, but later on it was realized that it shows particles are made of particles. I mean, you can simply say afterwards it says that it was realized that it shows that substances are made of particles which are constantly moving here and there. And that motion is called as Brownian motion. Right? Now, this is the end of the lesson in which what we have discussed. We have discussed solid properties, and we also discussed some pressure things and all that. One last topic which I wanted to discuss here is a heat, right? We talked about heat few seconds ago, that it is the total kinetic energy of a substance, right? But the point is, this is as per kinetic molecular theory, in which we can say the total kinetic energy of the molecules of or particles within the substance is called as heat. But what exactly is heat? How to define it? I can give you a very good example. Let's suppose you have a cup of tea in your hand, right? It has a temperature 60 degrees Celsius. You bring it in a you bring it in a room whose room temperature is 25 degrees Celsius. As soon as you bring that cup of tea in a room, the temperature start falling. The question is, till when this temperature will fall? The answer is, it will fall till the room temperature. So it will reach to 25 degrees Celsius, and afterwards you never see it falling. The question is, why it never falls? The reason is, it will achieve a thermal equilibrium. Now, what is that equilibrium thing? Equilibrium thing is when two bodies which are in contact have a same temperature. That condition is called as thermal equilibrium. In that case, energy lost is equal to energy gain. So basically, initially what happened, when the temperature of one body is more than the other one, heat energy is lost by one body and heat energy is gained by the other body. But once, excuse me, when two bodies have become the same temperature, then no heat gain and heat loss will be equal. So technically speaking, once one body has a higher temperature, the other body has a less temperature, heat energy will be flown from body of higher temperature to the heat energy of lower temperature, body of lower temperature. So you can say that heat energy flows from body of higher temperature to the body of lower temperature due to difference of temperature. So heat energy will be transported, or you can say transferred, from body of higher temperature to the body of lower temperature due to temperature difference. This is what the definition of heat is. This is the end of our lecture. Okay. In the next lecture, we will continue further about temperature scales, a small bit of them, and definitely some laws related to the gas. And then we proceed further and see what do we have next in this chapter. Okay. Hope to see you soon in the next lecture, which is our lecture number 15. This was lecture number 14. See you in lecture number 15. Bye.